Good morning and good Friday, everybody. Thank you for attending the webinar. The packaging materials manufacturing sector is getting very serious about responding to the call of the food industry for eliminating or mitigating the risks or hazards associated with the food contact packaging materials. As a matter of fact, the Global Food Safety Initiative has transformed the entire food supply chain, be it food manufacturing, packaging material manufacturing, storage and distribution, retailing, etc., into a very matured entity that is constantly evolving methods to mitigate the risks or hazards associated with the materials and thus protect the food supply chain. As the title of the webinar indicates, I will provide an overview of developing a robust HACCP plan by taking specific examples from the packaging industry. The packaging materials manufacturing industry is so vast and complex that I may not be able to come up with a model plan that is universally applicable to the various packaging materials. Okay. Because the time is too short, just an hour. I wish I had time to provide examples from the various packaging materials. Well, my name is Rama and I am the Technical Director of Perry Johnson Food Safety Registrars. We certify companies to the various GFSI, that is Global Food Safety Initiative, benchmark packaging standards, such as SQF, BRC, IFS, Pack Secure, FSSC 22000, etc. Now, the objectives of this webinar are twofold. First, to explain the various options for GFSI certification of your facility or systems, and also to provide some basic information for building a robust HACCP plan. It's well known that packaging is an essential component of food safety system, and good packaging ensures the packaging product is safe and wholesome. In fact, it protects the packaged product against cross-contamination from biological, chemical, and physical hazards. In fact, packaging is a system for protecting and preserving the safety and quality of food products throughout the life cycle of a food product. Packaging materials serve a variety of important functions. Number one, to protect food products from pathogenic microorganisms, that is the microorganisms or bacteria causing foodborne illnesses, food spoilage organisms, and also from pests beyond the manufacturing stage. So packaging is really important that way. It also protects products from oxygen and moisture ingression, because these are very active chemical entities. They may attack food products and spoil the taste, spoil the flavor, etc., etc. Also, packaging protects the integrity of food products during storage, handling, and transport. Okay? And as we all know, it provides valuable information to consumers, actually, label information. I think in the past, food safety professionals primarily focused on factors related to biological, chemical, and physical hazards associated with products, such as ingredients, processing, and food handlers. Okay. Packaging materials were always thought harmless. And while manufacturers were aware of the impact of defective packaging caused by faulty manufacturing operations, etc., on product safety and quality, awareness pertaining to incompatible packaging materials, or even the migration of packaging material components into foods and the associated health hazards because of that, they were not explored in greater detail until very recently. Let me talk about the various types of packaging. There are three types of food packaging. The first one is primary packaging. This type of packaging actually holds the packaged food products and therefore is in contact with the food product all the time. Then we talk about secondary packaging. This type of package collates the primary packages into a single container, individual pieces of packed food products going into a box, for example. Then there is a third type that's called tertiary packaging, which combines all of the secondary packages into one pallet to facilitate shipping and transportation. I'm sure you are aware of these things, actually. So a robust food safety program should take into account the potential hazards associated with all three types of packaging. Until now, the focus on food safety always centered on food products. I just mentioned to you in the previous slide. And again, people were referring to biological, chemical, and physical hazards associated with the various ingredients, processing, and staff involved, basically people involved in the manufacture of food products. So a more detailed analysis of all potential hazards in the food chain is required to develop and implement a comprehensive food safety management system. They thought by identifying biological, chemical, and physical hazards associated with materials, processes, and people, they would be able to eliminate all types of hazards in the food chain, and that was wrong. Because other things such as hazards coming from packaging material, for example, that was totally ignored. And packaging is a vital component in the food safety process, as you all know, and plays an important role in ensuring the safety and security of finished products. So thorough knowledge of the hazards associated with packaging materials and the effect of processing on the food produced or manufactured is therefore important to identify and mitigate the risks associated with packaging materials. I'm just going to provide a few examples to illustrate my point. Okay? The first example is use of proper laminates in the packaging of food products to avoid migration of hazardous chemicals into food. Or another example is use of approved printing inks in the manufacture of packaging materials meant for food products to avoid migration of harmful substances. And another example from the canning industry, use of approved lacquers for the interior of cans in the canning industry. I'm of the view that packaging professionals throughout the world have made significant advancement in identifying the risks related to the various types of packaging materials used by the food industry. For example, the Technical Committee of the Institute of Packaging Professionals, IOPP, in Chicago, has published a list of food safety risks that may be associated with the various types of packaging material. This is a very useful piece of information. In addition, it has also developed hazard analysis and critical control points, that is HACCP models, for various packaging materials such as cartons, rigid plastic, labels and cans and things like that. Wrong labeling of food products. This one. has led to a number of food product recalls in the past. I'm trying to emphasize the importance of packaging in the food industry, food safety. A good example is the recalls triggered by not declaring or wrongly declaring allergens on the packaging materials. In fact, as per FDA, 2/3 of the recall over a period of 6 or 7 years, they have done some statistics actually. 2/3 of the recalls were because of either wrong labeling or not declaring the allergen at all on the label. So packaging is so important in the food industry. Something about regulations. Whenever we talk about food safety, we need to talk about the associated regulations actually. I know this is not the forum for discussing the regulatory details, that is the details about the regulations applicable to the food packaging materials. In fact, regulations pertaining to food packaging materials are few and complex. Basically, there's a perceived notion that, or rather, people perceive there is a risk of transfer of components of packaging materials to the food that's packaged in it. That's the perception actually. Okay. The U.S. Food and Drug Administration, FDA, has the responsibility for the implementation and enforcement of regulations pertaining to the food contact packaging materials. Chemicals that are not intentionally added but expected to migrate into food, as well as substances intended to have a technical effect in the food, are regulated as indirect food additives under 21 CFR Part 174 to 178. Again, this is only some kind of reference, and if you want additional details, please refer to the relevant CFR. And in the past, indirect food additives were approved following indirect additive petitions, actually. Okay, people had to petition for approval. Whereas currently these days, food contact substances, actually, that's called FCS, may be used legally after notifying the US FDA via the food contact notification system, provided the migration into food, if there is an indirect food additive that you are using in the or on the packaging material, and there is a possibility of that migrating into food, if that level does not exceed 50 parts per billion, then approval is not required. Or substances that are generally recognized as safe, GRAS substance, for example, and this is covered under 21 CFR Part 178, or things that fall under the threshold of regulation exemption. Again, this is addressed in 21 CFR 170.39, with migration into foods below 0.5 parts per billion, they're also exempted from authorization. So I strongly recommend you to go through the relevant CFR, that is 174 to 178, to understand the regulatory requirements related to the packaging materials that you may be manufacturing. Okay. Now a few slides on the various GFSI standards. The Global Food Safety Initiative, commonly known as GFSI, harmonizes the standards pertaining to food safety through a process called benchmarking. The benchmark standards, they have wide-ranging acceptability in the market due to harmonization process. Basically, equivalency, actually. In the beginning, GFSI focused its attention on the harmonization of food safety management system standards. Okay, but the farm to fork approach to food safety necessitated the harmonization of the other related standards in the supply chain, such as packaging, storage and distribution, etc., etc. And in fact, in 2011, GFSI initiated the process of benchmarking of packaging standards against the GFSI guidance document, 6th edition. Okay. And these standards included BRC, which is British Retail Consortium, and that's known as Global Standard for Packaging and Packaging Materials, FSSC 22000, which is an ISO-based standard, and also the Safe Quality Food Program, commonly known as SQF. Okay. You are aware of the fact that packaging material manufacturers are constantly or increasingly under pressure from the food manufacturing customers to provide evidence of integrity of the materials they produce by conforming to one of these GFSI benchmark standards. Okay, and just a while ago I just mentioned only 3. The 4th GFSI benchmark standard is the IFS Pack Secure version 1. We're going to see these things in a while now. First, let me take up the BRC Global Standard for packaging. The British Retail Consortium is a trade association for the entire retail industry in the United Kingdom. And it works with the government also, the local government, to promote trade in the UK. In addition to producing these standards, and these are voluntary standards, as we all know, for food, they have also produced, or they have created a number of other standards, such as packaging, storage and distribution, consumer products, etc., etc. Okay. The BRC standard for packaging, Global Standard for Packaging and Packaging Materials, was originally published in 2001. And since then, it has undergone a number of revisions. The current revision is 5. Fifth revision has just been implemented, actually. This standard specifies the safety, quality, and operational criteria for packaging manufacturing organizations, basically to help them to fulfill obligations with regard to legal compliance and also for the protection of the consumer. Okay? And this standard is applicable to the manufacture of packaging and packaging materials used in the food packaging and filling operations throughout the world. Okay, it's not only for food. You can use the standard, you can implement the standard even for other products such as cosmetics, toiletries, and even consumer products, actually. Okay, and again, this is applicable to the production of packaging materials for conversion and printing. It is also applicable to operations that supply packaging materials from stock where additional product processing or repacking occurs. Another area. And also where manufacturers who produce consumer disposable goods that come in contact with food, example, paper plates, drinking cups, etc., etc. And again, you can also include converted or semi-converted products such as adhesives. So I think it has got a wide range of applications. That is the BRC standard. Again, there are 2 types of, the standard, the requirements are divided into 2 categories depending upon the intended use of the packaging. And these are, number one, high hygiene risk, which is packaging that comes in contact, direct contact with food products or other hygiene sensitive products. It's not only for food, even that comes in contact with skin, for instance, cosmetics. They're also considered or treated as high hygiene risk product. The other one is basic hygiene risk, which is packaging for consumer products and the secondary and tertiary packaging. So you can apply the requirement to those categories of products. Now, something about SQF, safe quality food. This is basically a code. This is not a standard. And this is a process and product certification standard, first developed in Australia way back in 1994. And this program is now owned and managed by the Food Marketing Institute since 2003. Okay. Again, there are two different levels, level 2 and level 3. I'm not going to get into those details, but basically just to let you know that there are two different levels of certification. Level 2 is primarily focusing on food safety. Level 3 is both food safety and food quality. And this code is based on a hazard analysis critical control point system. And if it is level 3, it includes quality management system as well. As a matter of fact, the SQF code recognizes the fact that food safety practices differ depending on the food safety risks to the product and process. I just mentioned to you in the beginning that this is a product and process safety related standard. So the code is designed to meet the individual requirements of each industry sector. It is vertically integrated. This is the only standard that is vertically integrated, outlining the requirements for various food sector categories in the supply chain, such as production, processing, packaging material, distribution, retailing, etc., etc. There are about 35 food sector categories. Packaging is just one of those 35 sectors, actually. Okay, and the specific food sector category or code is number 27. In order to meet the requirements, if a facility is interested in getting certified to SQF code, they may select the relevant module to their sector. Again, the documentation is available. If you want, you can visit the SQF website and get additional information. Module 2 is mandatory, which outlines the requirements for management system elements. And you will have to select the appropriate prerequisite program module applicable to your sector. If it is packaging, it is module 13, things like that. Now, let's move on to the next one, which is the IFS Pack Secure Standard. I think the acronym stands, the acronym IFS stands for International Featured Standard. This is a German standard, and the owner of the standard is IFS Management GmbH. And originally this was a Canadian standard, that is Packaging Association of Canada. That's why you see IFS Pack Secure. And IFS bought the ownership for this, and the scope is it can be applied, it can be used where facilities manufacture either primary or secondary packaging. And again, initially the standard was developed for food contact packaging material manufacturers, such as plastic foils for vegetables, cans for beverages, etc., etc. Now it can be applied to non-food contact packaging materials as well, that is cosmetics, household products, consumer goods, etc., etc. Okay. Whereas it's not applicable to the following activities. IFS Pack Secure is not applicable to the importation of materials, packaging materials primarily, and also it's not applicable to transport, storage, and distribution. And let's move on to the last GFSI benchmark standard, which is FSSC 22000. The scheme owner of this particular standard, that is Food FSSC, stands for Food Safety System Certification 22000, because this is based on ISO 22000 standard, and that's why that 22000 appears actually. Okay, this is in Netherlands, and it's applicable to a variety of products: perishable animal products, vegetable products, long shelf life ambient products, etc. And it can also be used for certifying companies manufacturing packaging materials. So if a facility is interested in getting certified, if a packaging material manufacturing facility is interested in getting certified to FSSC, then they will have to comply with these three different standards. 22000 ISO 22000 standard is again a management system requirement standard, because the requirements for management system, food safety management system, are documented here. And then there is a specific prerequisite program standard that is specific for the packaging industry, which is ISO 22002-4. This is the year of publication actually. Okay. And the last one is there are a few additional requirements from the foundation itself, that is FSSC 22000 Part 1. So the audit will be conducted against the requirements of these three standards. This is somewhat interesting. The next two slides, this is somewhat interesting in the sense I have done a detailed comparison of the 4 standards. Again, I'm not going to go through each and every piece of information on these slides. I just wanted to let you know that recently BRC revised the requirements, and now we have got 8 different categories of products: glass manufacturing, paper manufacturing, metal forming, rigid plastic, flexible plastic, other manufacturing, print processes, chemical processes, etc. So it's a very detailed standard actually, whereas the other 3 standards, they have these categories of products. And the primary focus of these standards is given here actually. Okay, BRC focuses on safety, quality, and operational criteria, whereas SQF focuses on the product safety at level 2, product safety and quality at level 3, and IFS focuses on safety and quality, whereas FSSC focuses on just product safety. But I just want to make a correction here, because FSSC has come up with another standard called FSSCQ, which combines the quality requirements also. And in the next slide, something about the duration. Is it a 2-day audit, a 2-stage audit, and things like that? Okay. Again, that's what is, BRC is a single-stage audit, whereas SQF is a 2-stage audit. At least the first year, initial year, document review, that's stage 1, and then the facility audit, which is stage 2, that is SQF. Again, IFS is a single-stage audit, whereas FSSC is a 2-stage audit. And the different grades that come out of these standards, come out of these audits. So that is also documented. And I think this information is going to be available after the webinar. Anybody interested in getting copies of the slide deck, etc., I think you may write to us. We'll be happy to send the information to you. Yeah, again, some comparison of the structures and things like that. Benefits of these standards. So now, which standard is right for you? Obviously, the decision is yours, right? Okay, so that is about the first part of the presentation, that is different GFSI standards and things like that. Let's move on to the next part of the presentation, which is building a robust HACCP plan. I'm sure you're all too familiar with the 5 preliminary steps of HACCP commonly encountered in the food safety management system of food safety plans. Actually, they are: number 1, assemble the team, HACCP team, describe the finished product, identify the intended use, construct a process flow diagram and plan schematic, and verify the flow diagram and also the plan schematic. So these are the 5 basic steps, actually. Okay, but I'm not going to spend time here because you're all very familiar with these things. I just wanted to provide a good example of product description in the next slide. Okay, remember the effectiveness of your HACCP plan, and some people do not want to use the description or the acronym HACCP. HACCP is basically for food safety. Here we are talking about, you don't manufacture any food product, but you manufacture products that are used by the food industry. So let's use the description product safety there. And sometimes people would like to call this plan as HAMP, that is hazard analysis and risk management plan. Okay, instead of calling HACCP plan, people would like to use another description called hazard analysis and risk management plan. Okay, so the effectiveness of your plan is directly linked to constructing a detailed and accurate flow diagram. So once you have constructed an accurate flow chart, it must be verified by the HACCP team or the HAMP team, and not just by one individual. Okay, so let me show you an example of a good product description. So this is an example of a good product description, and I have also done a number of packaging audits. Generally, I don't get to see this kind of detailed product description. Okay, let me take the example of flexible packaging. You know, this is from the flexible packaging category. What is the process? What process actually do you use in the manufacture of your material? You print, you are doing lamination there, which is based on adhesion. This is adhesive lamination. And after that, you slit the packaging material. So you describe the process like this. And then when you talk about the food safety characteristics, be very detailed. That is it direct? Is it indirect? Etc., etc. And you just see the way I have described here. Okay, so it should be as detailed as possible. And then what is the intended use? Where is it used? How is it used? It's used in the packing of shredded cheese, for example, or snacks or confections. And who is your target consumer? And what is the target market? Food processors, packaging for indirect food products, etc., etc. And what are the raw materials used in making this kind of thing? Okay, so use all the, I mean, provide all the information. And how do you package your product? It's all, you know, protected using corrugated sheets and things like that, okay? Shelf life. Generally, people neglect this, but again, it's good to say something about this. Like, for instance, depends on the end product use and customer requirements. Shelf life varies depending on the storage environment. Cartons are generally warranted for manufacturability for 90 days, something like that. Very specific, very detailed so that everybody can understand. And how do you store and distribute the product? I think it's a very good way of providing the description of the product. Okay. Now, this is an example of flowchart. The thumb rule is make it very simple, but at the same time, provide all the pertinent or relevant information. Again, I'm just, you know, for instance, you receive trailer and you inspect the product, and somebody is verifying the supplier's certificate of analysis. So that's the first step. Then you store your raw materials. Then from there, you make sheets. Roll stock is converted into sheets. And then you go for printing. Okay. Is there any CCP involved? That's what you're going to describe here. Okay. And then once it is printed, it's die cut. Okay. What are the CCPs there? Actually, you have to indicate the CCPs on the flowchart itself. And then I'm not sure, I'm sorry, I'm not saying you are using it, but this is just to give you an example of how you can make your flowchart as accurate as possible. And you ask a question, is it glue or hand packed? And if it is glue, it comes here. Hand packed, is there any CCP? Yes, because there is a barcode scanner. There may be some printed information that are critical for food safety, allergen information, for example. So that's why bar scanning will ensure that wrong information is not printed there, wrong information or wrong product is not going to be shipped to the consumer or a customer, okay? Now, after that, it is stretch wrap. Then also there is barcode scanning, and that's again, in this particular case, again, it's a CCP, and finally the product gets shipped. Simple, effective, quite visual. It gives all the relevant information, okay? So this is an example of a good flowchart. Sorry. Again, you're all quite familiar with the 7 principles of HACCP. In the previous slide, I just discussed about the 5 basic steps, the initial steps involved in HACCP plan, and now 5 plus 7, there are 12 steps, or these are called the 7 principles of HACCP. First step is identify the hazards. After that, you have to establish the critical control points. Once you have established the critical control points, establish the limits, because your job doesn't end with just establishing the critical control points. You need to monitor the effectiveness of your system. So that means you need something to measure, and these are the critical limits. After that, establish monitoring procedures. We are going to spend some time on all these things, and I just wanted to quickly run through the 7 principles of HACCP. And when there is deviation, then you implement your corrective action procedure. Then you have to verify whether the plan is working all right, and finally you keep records. So these are the 7 principles of HACCP. So what exactly is a hazard? Rather, hazard analysis is defined as the process of collecting and evaluating information on hazards and conditions leading to their presence to decide which are significant for food or product safety, so, and therefore must be addressed in the HACCP plan. Okay? So the intention here is, I'm talking about I'm going to show you examples for raw material hazard analysis and process hazard analysis. This one is for raw material hazard analysis. Okay. List every bill of materials here. I have just used the example of printed cartons here. So I'm using, this particular facility makes use of paperboard, etc., printing label. It continues. I didn't have enough space to accommodate everything. So I have just chosen paperboard and printing inks. Find out identify what the various hazards are. In this particular case, based on my experience, based on the technical information available and things like that, I know these are the hazards. These hazards may be present. I'm not saying they are present. They may be present, such as oil, grease, solvents. They come under chemical. Okay. And then, are there any foreign materials? There could be, because maybe insects, maybe something else. So identify all those things here. Any biological, any pathogenic bacteria. Generally in packaging materials, you don't expect biological contamination. Then you say no here. So when you have identified the hazards and categorized them into chemical, physical, and biological, then you go to the next column, that is column 3, and address this particular question. That is this hazard controlled by a prerequisite program or process step? So you have to say that. In this particular case, you are receiving, this is your raw material, which is paper roll, okay, roll stock. So you say yes, and that is mitigated through either a letter of guarantee, a certificate of analysis, and things like that. Similarly, even for foreign materials, you cannot verify each and every inch of your roll stock. So you have to depend on the supplier, and the supplier guarantees that there is no problem. So you accept the material based on that. Similarly, printing inks, because these are chemicals, there is a potential or there is a possibility of some of these contaminants present, heavy metals, for example. There could be off-flavor odor, a lot of solvents, etc., etc. So you mitigate the risk or you eliminate the risks based on, again, certificate of analysis and things like that. So you have to make use of this template for identifying and also documenting the various hazards that you have identified through these steps. Each and every raw material, that's why I said each and every bill of material has to be included here. Now, let me talk about process hazard analysis. You see here, sometimes people don't understand that they have to carry out hazard analysis of their materials, that is raw materials, and also the processes. Okay, so these are the different processes. Again, I'm not including, or I have not included each and every step here. I've just taken a couple of things actually: receiving, sheeting, printing. Now, go for the identification of the hazards like chemical, physical, biological, and things like that, and mitigate, address this concern. If you have identified some hazards, you have to say how you're going to mitigate or eliminate the risk. Let me talk about printing here, okay? Printing. I have identified chemical migration because it contains some solvents. It may contain some heavy metals, who knows? It may contain other substances, okay? Now, how do I mitigate the risk? You say here, yes, it is controlled by one of the process steps, that is proper curing and solvent flashing off. Maybe it passes through your material passes through a heat tunnel, and that removes all the solvents, etc., and that's how it becomes important. And you're removing it by subjecting the material to some kind of heat treatment. And how are you going to detect it? You may be using a GC instrument, gas chromatograph instrument, for checking the residual solvents. Okay, so include all the steps there. So we have done the raw material hazard analysis. We have done the process hazard analysis. Now, once you have done, you have also identified the critical control points. And again, what is the definition of critical point? Sorry, critical control point. It's a point at which the food safety or product safety is concerned. If you don't control at that step, it's going to result in food safety or product safety issues subsequently. So that is the definition of a CCP. Now, once you have identified the CCPs, then it becomes important that you establish critical control point. Sorry, you establish critical control points, then you establish critical limits, then you monitor the critical limits, establish monitoring procedures, establish corrective action, verification, record keeping, and things like that. So, and as you are aware of the fact that for determining CCPs, generally people use a decision tree. Again, I'm not going to get into that. Just give me a second. So once you have identified the CCPs, again, I'm giving an example here. You have to come up with what is known as the CCP Master Plan. This is an example of CCP Master Plan. My line clearance is one of the CCPs, for instance. And what hazard do you normally encounter? Probably mixed cottons. When you produce there, if cottons get mixed, you may be sending the wrong cotton to a facility. And that, if that facility uses allergens, for instance, and if the printed cotton does not have the label declaration, then it's a serious food safety issue. And if it is not detected even in the other facility also, then it's going to result in a food safety issue. So that's why line clearance, in my opinion, or I have identified line clearance as a CCP. And what is my critical limit? I don't want even a single mixed cotton there. So that's my critical limit. It doesn't have to be subjective. Critical limits are mostly objective. That means you'll see numbers all the time. Like, for instance, if you want to if you want to remove solvents, you may have to make use of a suitable temperature and the web speed. These two things will determine the rate of evaporation of solvent, for example. Okay, so you can assign numbers, but occasionally it could also be subjective like this. Okay, then you have to go for, I told you that there is going to be a monitoring procedure. And the monitoring procedure will define what is to be monitored, how is it going to be monitored, and the frequency, at what frequency that will be monitored, and who is going to do that. So again, I have two examples here. One is graphics control, which is basically for verifying the artwork and things like that. The other one is line clearance during production. So you're going to define all these things in a monitoring. And then the corrective action thing, should there be a deviation here, what do I do? Then you go for the corrective action procedure. You may have a detailed procedure separately, but you have to state that in your master plan. And finally, how is it going to be verified? Okay, when there is deviation, how is it going to be verified? Define everything. This is an example of your master plan. And sorry. And out of those 7 principles, one of the principles is verification. And I'm just going to talk about validation here. One second. Validation is a part of verification. In short, verification confirms that the HACCP plan is being followed, whereas validation confirms that the HACCP plan properly addresses the appropriate activities. Okay, both verification and validation activities must be documented. Okay, verification includes activities such as annual internal audit. It's an example of verification to confirm the HACCP plan is being followed as written. You have a documented plan, and is it working as per the plan? That's called verification. Okay. Or it can also be, verification can also be evidenced through the confirmation of operator training, for example. And there are so many examples, again, HACCP record review, spot checks, and there are, you can, there are umpteen examples for verification. I've just given a few examples. So, again, validation includes activities such as critical review of the hazard analysis for depth and accuracy. Okay, for instance, were all hazards considered? Where the correct CCP is chosen? Sometimes people do not choose CCPs correctly. Okay, critical evaluation of CCPs. Okay, that means are critical limits meaningful and actionable? And what about monitoring activities? Are the correct parameters monitored and at the correct frequency? Things like that. These things will be included in validation. So when you want to validate your HACCP plan, you must raise the following questions. You must ask the following questions with your team. Are CCPs meaningful and measurable? Have all risks been identified and evaluated? Have raw materials changed? Has process or equipment, whether any of these things changed? And things like that. and again, keep documents, keep documents, keep documents. Documents as well as records. A record is also a part of document. Okay. This slide is about HACCP plan reassessment. And this needs to be reassessed. That is, the HACCP plan must be reassessed on an annual basis. All these standards require you to reassess on an annual basis. When there are changes to the plant, when there are changes in key processing equipment. If you're changing your printing machine, for example, you must revalidate your plan. Changes to primary raw materials. You are changing your roll stock from one thickness to another thickness. You have to revalidate. Okay. Or when you get industry alerts, some industry recalls, big recalls. So when you encounter any of these situations, that requires you to revalidate your HACCP plan. Intentionally, I kept this slide here because PRPs, what is the definition of PRP? PRP is nothing but, the PRPs are nothing but procedures including good manufacturing practices that address operational conditions, providing the foundation for the HACCP system. So the whole thing about HACCP is identify hazards, mitigate the risk to ensure product safety. Okay, PRPs definitely help you in eliminating or mitigating the hazards associated with your product, processes, and people. Okay, so these are GMPs actually. I'm just going to give you a list of prerequisite programs. Again, I'm not saying this is comprehensive. PRPs are unique. PRPs are unique to your facility, unique to your process. You need to identify what PRPs are important for you and applicable to you or appropriate for you. Okay, so these are some examples of prerequisite programs. Training, personal practices, GMP, cleaning, sanitation, transportation, traceability. All these things will help you in mitigating the risk in the first place. When the risks or hazards are not fully addressed by PRPs, then you get into CCPs and things like that. So I hope the information was useful, and thank you very much for your time. And if you have any questions, please. Any questions? I don't see any questions on the question box. So if there is nothing else, thank you for your attendance, and I really appreciate it. Have a good Friday. Thank you very much.